This is a simple calorimeter concept. So now we have a simple calorimeter. Okay. So simple calorimeter is suitable for measuring enthalpy change that takes place in an aqueous solution. So as we know that an aqueous solution is suitable for the measuring of enthalpy of neutralizations that involve an acid and base solution. So the system is reactants and products, and the surrounding is the solution in the calorimeter and the calorimeter. So for an exothermic reaction, since that neutralization process involves an exothermic reaction, so the system will lose the heat and the surrounding will absorb the heat, and it will cause the increase in thermometer reading. Let's look at on how to calculate the heat of neutralization. So as we know that the neutralization process involves acid and base that produce salt and water. So the neutralization involves a releasing heat. So for an exothermic reaction in solution in a calorimeter, the heat produced by the reaction is trapped in the calorimeter. So sebenarnya bila kita campurkan asid dan base, dia akan menyebabkan calorimeter itu dirasakan panas. Okay. So panas menyebabkan dia release heat. So the heat yang release tu is trapped in the calorimeter, menyebabkan the temperature of the solution increase. Okay. So heat released by neutralization reaction is equals to the heat absorbed by the solution and calorimeter. So the solution here is referred to the water produced from the reaction of acid and base. So we have the formula of Q equals to mc delta T plus mc delta T. So here S, this one mc delta T for the solution, and here is mc delta T for the calorimeter C. Or we can use the formula of Q equals to mc delta T plus C delta T. This one mc delta T for the solution, and this one is the C delta T for the calorimeter. So the difference between these two formula is we can see that for the solution it is the same. Okay, we use mc delta T, but the difference here is for the calorimeter. So it depends on the questions given whether the question give a specific heat capacity of calorimeter. So we can use the formula of mc delta T. If the question give the heat capacity of calorimeter, so we can use the C delta T. So this one is represent for the formula. So let's look at about the Bohm calorimeter. So we have two different types of Bohm calorimeter. The first one is the Bohm calorimeter with water. So we can see that the Bohm calorimeter have surrounded by the water. The other one is the Bohm calorimeter without water. So let's look at the Bohm calorimeter concept. So this is a Bohm calorimeter with water. Since that we can see the water is surrounded the calorimeter. So Bohm calorimeter is a device often used to determine the heat of combustion of fuels and energy content of food. As you can see in the previous slide, the simple calorimeter is used in neutralization process since that it involves a solution, but this Bohm calorimeter involves the heat of combustion. It involves the gas. So the system is equals to the burning sample. So here is the burning sample and the surrounding is the water in the calorimeter here and the metal parts of the calorimeter. So since that the combustion process involves releasing heat and an exothermic reaction, so the system will lose the heat and the surrounding will absorb the heat and it will cause the thermometer reading to be increased. Let's look at on how to calculate the heat of combustions. So the heat produced by the combustion reaction is trapped in the calorimeter and it causes the temperature of the water or calorimeter increase. So both calorimeter with water, heat released by combustion is equals to the heat absorbed by water and calorimeter. So the formula used is the heat release equals to mass of water, specific heat capacity of water delta T. Okay, this one is for water. And plus with MC delta T, this one is for the calorimeter. Or Q is equals to MC delta T, this one for water. And C delta T, this one for the calorimeter. So the difference of this formula is depends on the questions given, whether the question gives the specific heat capacity of calorimeter, so we can use this types of formula. But if the question gives the heat capacity of the calorimeter, so we can use this types of formula. For Bohm calorimeter without water, heat released by the combustion reaction is equals to the heat absorbed by the calorimeter only. So the formula involved is C delta T or MC delta T. This one refer for the calorimeter only. So this is the same as this. It depends on the questions whether it gives the specific heat capacity of the calorimeter or heat capacity of the calorimeter.